Hello, explorer. Welcome along. It's the part of the week where we leave planet Earth for just a little while, because we need to do a tour of the universe. Let's search out those secrets. It's a brand new Fun Kids Science Weekly. My name is Dan. This week, you can uncover a cosmic mystery with Chief Scientist at the UK Space Agency, Amara.
Our planets and the sun were made from a giant ball of gas that spun a little bit. And then what gravity does is it pulls everything together and everything begins to spin together.
And in Battle of the Sciences, our quest to discover the greatest science in the history of the universe, we're diving into the myths around staying clean.
Washing, and not just with water, but also with soap or detergents. What they do is get rid of any kind of oils and so on in your skin, and that actually is what's key.
For our Dangerous Dan, we'll head to the swamps around Africa. It's all going on in a brand new Fun Kids Science Weekly. Let's start with your science in the news. A primary school in London, UK, has told its pupils to stay inside during breaks and lunchtimes because there's a dive-bombing buzzard in the playground. There are concerns that the bird is guarding its nest. It might attack anyone nearby that it thinks could be an intruder, and buzzards are raptor birds. They can weigh more than 1 kilogram, they can have a wingspan of over 1 meter, and they can be vicious, so there's a chance that they'll be dive bombing through the air at anyone who just wants to play at break time. Isn't it amazing that we know so much about animals around the world, yet still they can be completely out of control? They can really do what they want. I love that about the animal kingdom. Also this week, in Italy, Mount Etna has erupted, with large plumes of ash seen rising from the volcano. Volcanic material was seen spilling from it on the island of Sicily just a few days ago. The full scale of the eruption is currently unclear, but Mount Etna is one of the world's most active volcanoes. Eruptions are not really uncommon, so people just get on with their lives as normal. Imagine if you lived near a volcano and it erupted and you were just like, yeah, fine, it's erupting. Do we need to go to the shops? Do you fancy some dinner? Life carries on. Again, it's one of the best parts around science is that people, we get used to everything, and still we're always wondering why. And our final story this week, a group of scientists are trying to solve a mystery 72 million years old. They've travelled to Pipestone Creek in Canada, where there are thousands of dinosaur fossils buried. All the creatures were killed in a day of devastation all those years ago. The big question is why. Let's find out. Professor Emily Bamforth is leading the dig. Emily, thank you for joining us. Can you tell us about the first moment that you heard of this huge grave of dinosaurs in Pipestone Creek?
So the Pipestone Creek bone bed is actually quite a famous dinosaur site, at least here in Alberta, which is where we are right now. So I actually heard about it when I was a student in paleontology, but I didn't actually get a chance to visit until just a couple of years ago. So it was a very, very exciting time to go and visit this bone bed.
So you're leading the dig, right? And it's massive, thousands of dinosaurs. When you get given that job, how on earth do you begin to plan something like this?
So the Pipestone Creek bone bed is incredibly dense. Like we're talking about something like 100 to 300 bones per square meter in this particular bone bed. So we have to plan really carefully. It's kind of like a game of pick up sticks, which is where you drop a bunch of sticks and they all fall and you have to pull them out individually. That's exactly what collecting fossils at Pipestone Creek is like. So we have to very carefully plan how we're going to extract the bones without breaking other bones. And, they're all piled on top of each other, so you have to figure out which bone is going to come out first. And so we spend all summer doing that, like very carefully working around this giant jigsaw puzzle, trying to figure out how to get these bones out of the ground intact so that we can bring them back to our preparation lab and prepare them out.
What do we know about which dinosaurs are actually there? Do we have any ideas of different species yet?
So the Pipestone Creek bone bed primarily has one kind of dinosaur. It's called a Pachyrhinosaurus, which is like a smaller, older cousin of the Triceratops. except instead of having a horn on its nose, it has this huge bony bump that we call a boss. And that's something that's unique to this species of dinosaur. And it's actually an endemic species, which means that it is found here and nowhere else in the world. So that is mostly what is in Pipestone Creek is a Pachyrhinosaurus. However, we have found the remains of a little raptor-like dinosaur in there as well. We also find fossils of turtles, of fish, and of these crocodile-like creatures called champsosaurs in there as well. But again, primarily it is Pachyrhinosaurus in this one bone bed.
The big question, the mystery is, how did all of these creatures die in such a short space of time? How are you going to know that? What are you doing to the bones and the fossils to try and figure it out?
Yeah, so what actually happened at Pipestone Creek is one of the mysteries that makes this bone bed such a great story. So we think that it was a migrating herd of Pachyrhinosaurs. So all of the animals died all at the same time. It's not like they kind of died periodically and got piled on top of each other. We think they died all at once. And we think what killed them was actually a big flood that came in. So these animals, we think, were on a seasonal migration, like maybe going up to their summer feeding grounds or maybe their nesting grounds. And they were unlucky enough to be caught in a flash flood. So this area back then was actually prone to this kind of flooding. This is one of the reasons why we have so many dinosaurs in Western Canada, is that these flooding events were reasonably common. So we think our Pachyrhinosaurs were unfortunately in the path of a giant flood. And so that's why we sometimes also call the Pipestone Creek bone bed the River of Death. It's because we think all these animals died in this giant flooding event. They all died at the same time. They were lying out on the floodplain for a while. They started to get scavenged by other carnivorous dinosaurs. And then eventually all of those dead, decaying carcasses were picked up and buried. And that's what we find at Pipestone Creek today.
So we think that because of evidence of where the creek is, that it was known as this floodplain. You've dug up all the bones. Can there be any sign in the fossils there of maybe how they met their end?
So the mysteries, or the clues to the mystery, is actually in the rocks. So the rocks that we find at Pipestone Creek are rocks that form in a kind of flood environment. So if you look at the rocks just above the bone bed, they have all these kind of crazy muddy swirls and stuff in them. There's also a lot of fossilized plant material, like evidence that there was big trees that were kind of picked up and dumped in the same deposit as the bones. So something that was really high energy happened to these dinosaurs. And so the most likely scenario, given the time period and the environment that they were living in, is that it was a flood a flood event. And, you know, the fact that this is how many herding animals today meet their demise, they got caught in floods. If you think of things like caribou or wildebeest. So we have kind of modern analogs as well that kind of give us a hint about what might have happened to these dinosaurs.
Wow, Professor Emily Bamforth, been up and down the River of Death. Thank you for joining us.
Yeah, no problem. Thanks for having me.
Thank you to Emily Bamforth for taking us into a dinosaur grave at the River of Death. What else do you expect if you're going to call something the River of Death, eh? Right, it's time to get your questions sorted then. If you have anything sciencey that you want answered on the podcast, make sure you leave it as a voice note for me. You can do that on the free Fun Kids app. Make sure you click record, leave a message, it'll come through to me, and I will get a genius that will sort it out for you. One of those in a sec. First up is from Etta and Chester, who sent this as a message to me. What happens if you dug to the middle of the Earth? Well, the deepest man-made hole, it's called the Kola Super Deep Borehole. It's in Russia. It travels down about 7.5 miles. It was made with very special drills that had to be replaced all the time because when you get down that far deep, it's really hot. There's so much pressure. There's so much happening, and it just damages anything that's nearby, really. Now, what would happen if you could deep so far down into the Earth? Or let's put it like this. If there was already a hole that went right the way through the Earth, what would happen if you jumped down it? Well, things aren't that nice. About half a kilometre in, not even that, you would get something called hyperoxia, where you have too much oxygen. You can't survive with it. Then the further you fell into the Earth, the air everywhere, the pressure of it would crush you. But let's say you wore an oxygen tank. Let's say you had a special suit on that would help you survive the pressure. Well, about a kilometre down, 0.02% of the way into the Earth, you would get so hot it would get to 320 degrees Kelvin. You can't survive that. So let's imagine you have a suit on that could deal with the heat and all the oxygen and everything else that wants to kill you. You would travel down faster and faster, getting to around 200 miles an hour-ish, something like that. But then you would get resistance, air resistance, drag that would hold you up. It would slow you down. Those 200 miles an hour would slow down very, very quickly. And you would actually come to a stop. You probably wouldn't get near the Earth's core. You would just be floating around. Perhaps the gravity would drag you down towards the core, but even if it did that, you would swing out the other end. You would be a pendulum. So there's a lot that's strangely up in the air, even though we're underground about this, Etta and Chester. It's because no one's done it. Hopefully no one's going to do it because it is supremely dangerous. There wouldn't be anything left of you after about 20 seconds of diving down that deep underground, seriously. But thank you very much for the question, guys. Listen, let's get on one that's been sent in as a voice note to me on the Free Fun Kids app. This is from Wilbur.
Why does the Earth spin but not the sun?
Well, Wilbur, thank you so much for your question. Why does the Earth spin but not the sun? That's one question I have never considered, Wilbur. So shall we sort it out? And we're going big today with Chief Scientist at the UK Space Agency, Professor Adam Amara, who joins us. Adam, thank you for being there. So our Earth spins, but the sun doesn't? Can this be true?
It's not true. The Earth spins once a day. Now, what is true is the sun spins slowly. It spins about once a month. So an interesting question is, how come the sun spins so slowly?
Right, so why is the sun spinning so slowly? I mean, it's enormous.
It is enormous. Well, first of all, it's good to understand how common is spin. And in astronomy, basically everything spins one way or another. Planets spin, galaxies spin, protoplanets spin, stars spin, and black holes. Everything spins. And the reason for that is that there's an idea, when you move, there's a thing called momentum. When you move, you want to stay moving. And if you want to change something's direction, it's really hard and you have to work at it. When things start to spin, they have the same thing. The technical term is angular momentum. But when things spin, they like to stay spinning. And our planets and the sun were made from a giant ball of gas that spun a little bit. And then what gravity does is it pulls everything together and everything begins to spin together. And the question is, where does all that spin factor go into? And it turns out the spin factor mostly goes into the orbits of the planets. So about 98% of this spin factor goes into the orbit of the planet. And a little bit is left for the sun and a little bit is left for the spinning of the planets.
Now, does the sun's motion, its spinning, have an effect on other things around it, us down here on Earth? Would things be different if it wasn't spinning?
We are subject to what's called space weather. So every time the sun moves or bubbles, because it's quite a dynamic thing, and it shoots particles into the solar system, how it shoots it and where it goes has a big effect on us. It can affect our satellites, it can affect our planets, it can affect our night sky. And so what we can sometimes see, what we want to know is that activity going to point at us? And if we know it rotates once a month, we can sort of begin to see activity point at us. So it does make a big difference knowing where sun's energy is directed.
Now, it's not just the sun that spins once a month. The moon does that too. Now, is there some grand connection across the universe? Why 30 days-ish is so important?
It's a coincidence. So the month is about an average, because what you've got to remember is the sun is a ball of gas, a big plasma. So it doesn't all spin the same. So the poles spin a little bit slower than so this differently to the equator. The moon is spinning really slowly because it got locked to the Earth. And so its spin is completely determined by how long it takes to go around. So it goes around the Earth and always shows us the same side. And that's because it got locked into the Earth by a process called tidal locking. So it's a bit of a coincidence, but yeah, roughly each one about a month.
Well, there you go, Wilbur. Why does the Earth spin but not the sun? Well, we both spin, but the sun just very slowly. Professor Adam, Amara, thank you for joining us.
Thank you for having me.
Well, thank you to Adam. What a brilliant guest on the show. Chief Scientist at the UK Space Agency, asking one of your questions. That's the pulling power that we have here. So if you want anything, make sure you leave it as a voice note for me on the free Fun Kids app and at funkidslive.com. And while you're on the website, have you got your tickets yet to Fun Kids Science Weekly Live? We're less than 1 month away from the very first show. Are you ready for a summer stuffed full of science? I am bringing this podcast to towns and cities all around the UK. We're going to have so much fun. We're going to do so much smart science. We'll have experiments, we'll have dangerous beasts, we'll have genius guests, and something from outer space on stage with me. You can touch it. It will be extraterrestrial. Things will get slimy, things will get quite stinky, and I really can't wait for you to be there. The first time we've ever taken this show on tour. So you can see the greatest podcast in the history of the universe. I've got the award and everything. Live. Come along. Spend your summer with science and me. Find out where I'm playing near you on our website. Get a grown up and head to funkidslive.com/tour. Now for this week's Dangerous Dan, where we search for the most unique, weird, strange and deadly things in the universe, we're headed to the swamps of Africa to meet one bird who looks just like a dinosaur. Let me introduce you to the shoebill stork. They're a pinkish, grey, blue bird that stand stone still on its 2 legs. They've got wide wings with feathers that individually jut out. They get their name, the shoebill stork, from their massive beak that looks just like a fat shoe. It's enormous, this thing. It slices straight into the sky. It's round and it's sharp, and the stork glares over it with piercing eyes. I promise, it looks just like a dinosaur. Their smart science name, in fact, the Latin one that all creatures have, is Balaniceps rex. It's even got rex in the name. So they stand still, the shoebill stork, stopping dead still, motionless, for hours at a time. And they're waiting. They're waiting until some prey comes nearby. And then they strike with lightning speed, shoving its beak out and snapping it shut. It can crush the skulls of fish, mammals, and even crocodiles with one bite. It may look like a silly dinosaur, but it's a stealthy, brutal beast, and that means the shoebill stork from the swamps of Africa goes straight onto our Dangerous Dan list. It's time for this week's Battle of the Sciences, where we try to discover the greatest science in the history of the world once and for all. We will figure it out. This week we're looking at your body. What makes you well, what makes you sick, and how you clean yourself. We're talking clinical microbiology with Dr. Primrose Freestone, who joins us. Primrose, thank you for being there. You have 1 minute to tell us why clinical microbiology is the best of them all. That minute starts in 3, 2, 1, go!
Clinical microbiology is all about understanding why you keep yourself clean, why you wash your hands. The world around us is full of microorganisms. These are bacteria, fungi, viruses, and most of them are harmless, but some can be very harmful. Think about COVID-19, think about listeria, MRSA, think about food poisoning. That's all caused by germs, and hygiene is very important. So my sort of expertise is all about understanding why hygiene is important and how to keep you safe from those small number but still very dangerous germs that are out there, that are all around us.
Primrose, thank you for your minute, coming in at about 50 seconds. So, the word germs doesn't sound very scientific. It sounds like a bit of a catch-all term. Are there good germs? But we only really think of them as being bad. But can there ever be good ones? Germs
actually do refer to what are called pathogenic microorganisms. Microorganisms are life forms that you can only see using a microscope. So I'm interested in understanding in how we actually sort of fight off these germs, these pathogenic bacteria and fungi. Think of, in terms of the bacteria, of E. coli, Staphylococcus, MRSA, Clostridium difficile, and the viruses. Well, there's cold and flu, and of course, a few years ago, we were all of us kept home because of COVID-19, which is basically an envelope virus, a little bit like flu. I'm interested in how our bodies react to those germs, and at the same time, how we can keep ourselves safe from them. And hygiene, how you wash yourself, how you keep your clothes and your kitchens and your bathrooms clean, is all part of that procedure to keep yourself safe from germs.
You talk about how our body reacts to germs. For these very specific pathogens, why is it that our body doesn't normally know what to do, especially the first time round? Why do these things make us sick?
Bacteria, and especially viruses, okay, because bacteria we can treat with antibiotics. Viruses we can't, and our immune system has got two levels of protection. One is called the innate immune system, and the other is the adaptive. The adaptive is the one that you have your vaccinations for. So when you get an infection or when you're given a vaccine, your immune system, which is the protection of cells and proteins in your blood and circulation and tissues, their role is to actually stop germs growing inside you and causing infection. So therefore, either actually getting the infection, for example, a virus like the flu virus or COVID, or getting the vaccination against it, does the same thing. It exposes your immune system, the adaptive part, which involves antibodies, to the germ, the pathogen, and your immune system then actually goes into a range of sort of roles and works out what is actually foreign. So in other words, it learns and actually keeps a memory of the infection. And then afterwards, if you get the infection again, your immune system's primed and ready to go, and you basically are much less likely to get that particular infectious disease.
And you said that you're very interested in hygiene and how we clean ourselves. Now, surely cleaning ourselves with water gets rid of any germs that might be floating around. What are you doing as a clinical microbiologist to discover better ways that we can keep ourselves clean?
Well, it's good for your immune system to get workouts, I have to say, from being exposed to germs. But at the same time, too many germs can actually, in terms of numbers, can overwhelm your immune system, and so you get ill, you get an infection. Washing, and not just with water, but also with soap or detergents, what they do is actually sort of get rid of any kind of oils and so on in your skin, and that actually is what's key in terms of actually washing. So you need to wash with a detergent, soap, hand wash, pretty much anything, quite frankly.
Now, we always finish these chats, Primstone, in exactly the same way. Let me throw you forward a few years, whenever it is that you decide to hang up your lab coat and your microscope where you're looking through at your germs, and you stop being a scientist, right? What's the one thing that you really want to discover? What's the one question in the field of clinical microbiology that you'd love to answer?
Well, I've already done it, actually. I'd like to discover a new antibiotic, and I've actually indeed done that, and it's been patented.
Well, tell us about this brand new antibiotic.
I can't tell you because it's secret, but what it does do is kill off any pathogens that are already resistant to antibiotics. You might have heard of the antibiotic resistance crisis that's out there because of overuse of antibiotics. It means that there are some pathogenic, nasty pathogenic germs out there, such as E. coli and Salmonella, and also Staphylococcus aureus, think of MRSA, for which there's no more antibiotics. But I've discovered one, actually, that can kill off all of those, and it doesn't actually harm people.
Well, What an exciting end. And maybe it's a brilliant fight and proof of why clinical microbiology is the greatest science of all, because we're making discoveries still. Dr. Primrose Freestone, thank you for joining us. Now, we've had a few bits of dino action on the show today. We heard about the shoebill stork earlier on. Looks just like a dinosaur. I mean, promise, look it up. Looks just like a dinosaur. Also, earlier on, we heard from Emily Bamforth, didn't we, about the dinosaur mass grave up in Canada. Well, let's time travel and learn a bit more about dinos now with an episode from our Age of the Dinosaurs series. We're heading back to the Jurassic period, which was home to thousands of different dinosaurs, big, small, thin, wide, and we split them into two groups normally, carnivores and herbivores.
Imagine going back in time, not 100 years or 1,000 years, but millions of years. To the age of the dinosaur. The Jurassic period was home to thousands of different dinosaurs, big and small. One easy way to learn about them is to split them into two groups, the meat-eaters or carnivores and the plant-eaters or herbivores. Of course, some dinosaurs are both. Look out! Here comes a well-known carnivore, the Megalosaurus.
He's getting very close, and he's enormous.
Megalosaurus was a terrifying predator that was almost 9 meters long. That's twice as high as a double-decker bus. He had powerful jaws and sharp teeth, perfect for ripping through his prey's thick skins and swallowing huge chunks of flesh. His teeth were serrated. That means zigzag-shaped along the edge, like a saw, and could slice through flesh easily. Standing on his hind legs, with short forearms and a huge head, he looked quite like Tyrannosaurus. Although since T-Rex wasn't to appear for many millions of years, they would never have met. As well as razor-sharp teeth and strong jaws, predators have large eyes for finding their prey. We can tell this in dinosaur fossils from the shape of the bones in the skull, which reveal the size of the eyes. The eyes would have faced slightly forward, like in a bird of prey. This allowed them to judge distances accurately, helping with hunting.
Ugh, what's that horrible smell?
Another sign of a meat-eater is found in their brains, whose impressions are left deep in the skull. The part of the brain involved in smelling was very large in carnivores. Many meat-eating dinosaurs would eat dead animals as well as live ones, so sniffing out rotting carcasses, sometimes as much as a kilometre away, was important.
Watch out, there's some giant feet heading this way.
You might think the herbivores sound a bit less scary, but they were some of the hugest creatures that ever lived. Diplodocus is one of the best-known herbivores, a huge sauropod who stood a whopping 26 meters long with a long neck, perfect for reaching leaves at the top of tall trees. Lots of herbivores had many rows of teeth, sometimes pencil-shaped to rake the vegetation. Other times rounder or blunt-like spoons to rip leaves from the branches. Teeth were constantly replaced as they broke or wore down, which would have happened a lot. To get enough vegetation to keep their huge bodies going, those teeth would have been busy. Whilst broad-snouted sauropods wouldn't have been picky eaters, those dinosaurs with narrower mouths could pick particular plants, and so may have had a favourite. Others, like the Stegosaurus, had horny beaks that could slice through the toughest vegetation.
Paleontology, pick.
How can paleontologists be so sure about what dinosaurs ate? Well as the shape of their skeletons, size of stomach cavities and the type of teeth, there's another way. Because what goes in must come out. That's right, fossil poo. Called a coprolite, it can help scientists understand the relationships between animals and plants. Seeds, bones, fish scales or vegetation can be identified and give us an accurate picture of what a dinosaur liked to eat.
That's an episode from our Age of the Dinosaurs series. You can hear more of them and travel back through time whenever you like on Google, Apple, Spotify, wherever you get your shows. Tons of brilliant podcasts on there. Also, remember, get your tickets to the Fun Kids Science Weekly Live, taking it on tour. It's a summer stuffed full of smart science. I can't wait to see you there. Get to funkidslive.com/tour for that. And Fun Kids, we're our children's radio station from the UK. You can listen on the website, on our app, and if you've got a smart speaker, wake it up and ask it to play Fun Kids.